Hello, how are we doing today? Today we're going to be in section 7.3 in our textbook, add and subtract radical expressions, and multiply and divide binomial radical expressions. So basically, without the use of a calculator, at the end of this, you will all be able to add and subtract and multiply and divide. So let's go ahead and get started. Okay, we want to add or subtract if possible. Well, basically, I want to look at this first example as if I'm looking at maybe, let's go 7z plus 3z. In other words, I'm looking to combine like terms. So if everything is the same with the square root sign in this case, and the x and y, then I can add them and combine like terms. So I get 10 square root of xy. Down here, the contrast to that in example B, I have a problem. My basic problem is my index is the same. That's good. But x and 5 are not the same under the radical. So I can't, that's kind of like taking 2p minus 2q. If I said simplify, you'd say, Mr. Roderick, I'm done. I can't, there's nothing I can do with that. So this is not possible. So in order to add or subtract, we have to have everything, all the exponents, the indexes, the symbols, all the same in order to add or subtract in combined like terms. Here's a question that takes us from this addition subtraction, an application that goes back to geometry. This rectangular window shown below is made up of 3 equilateral triangles, so 60, 60, 60 in equal sides. And like this, right? Those are the same. And this is the same. And then two right, what does it say? I'm sorry, two right triangles. So I have right angles right here and right here. And the equilateral triangles have lengths of 4. So this is 4, 4, 4, etc. Well, if this is a right triangle, how am I going to find the perimeter? So I need to find this guy, and these two guys. So I need the sides of the right triangle. Well, I know that this guy here must be 4, as is this. These are the same. So, well, if this is 60 and they say it's a rectangle, then this guy right here has to be 30, right in there. I got 30 here, a right angle there, so I must have 60. And there's a myriad of reasons you could know that. Alternate interior angles, what the argument I'm making here, but right in here must be 60 degrees. So I have a 30, 60, 90 triangle in here. Okay, like here, 30, 60. I'm just blowing up this triangle. So let's see here. Um, we know that this is 4. So if I remember my model, this is the hypotenuse side, or the 2. This was the 1, and this was the square root of 3. You guys have to know those special right triangles. Okay, so if this is the 4 to 2, then this is 1 to 2 down here. So I can go back and label this guy right here as 2. Okay, which means this is 2. Okay, then over here, this must be, on this left-hand side, this must be 2 times the square root of 3. So this is, again, 2 times the square root of 3 on this side and over on this side. So now I can go ahead and get my perimeter by just adding up the blues. So I got 4, 4, 4, 2, 2. So 12 and 2, I got 16. And then I've got 2 square root of 3 on each side. 2 square root of 3 plus 2 square root of 3 is 4 times the square root of 3. Those are like terms. I can do that. Okay, and if you wanted to go ahead and put that in decimal form, you'd come up with about 22.9 feet. But our skill today, obviously, is adding and subtracting radicals, so we want to be able to do that and so forth and so on. Moving along. Okay. This is a full lesson, so I'm trying to move quickly to make sure the video isn't too long for you. All right. So now, example 3. Again, these look like not like terms we just talked about. The only problem is these 20, the 45, and the 80, you guys all know that those are not fully simplified. So if I take this first one, and I know you did this in geometry, so this 3 stays, and the square root of 20 breaks down into, just quickly, square root of 4, square root of 5, so 2 square root of 5, so 3 times 2 square root of 5. Same thing happening here. This breaks up into square root of 9, square root of 5. Square root of 9 is 3, so 3 square root of 5 here. And this breaks into, I'll go ahead and work this down here, 4. And square root of 80 breaks up into 16 and 5. So 4 times the square root of 16 is 4. Square root of 5. So I get 16 square root of 5 there. So now 3 times 2 is 6, and I can add all these together. 6 and 16 is 22 minus 3 is 19 square root of 5. Now, again, these are all like as far as the radical sign, so I can add and subtract, basically combining like terms is what that becomes. Let's go ahead and move on to multiplication. Okay, so multiplication, okay, is going to work, so I have binomials here. I'm going to multiply. So we all know we're going to distribute, or we shortcut call it FOIL. So 2 times 1 is 2. And 2 times, I'll just do this down here in the margin here, minus negative 5 square root of 3. Well, what does that mean? 2 times negative 5 is negative 10. So negative 10 square root of 3. Okay. Now I have to come back and take this guy, bring him through. So plus 4 square root of 3 and minus 20. And what is the square root of 3 times square root of 3 is 3. Okay, let's work that one off to the side because this is the one that seems to give us a problem. The 4 square root of 3 times a negative 5 square root of 3. So multiplication is commutative, right? So basically this becomes 4 times negative 5, so negative 20. And square root of 3 times square root of 3 is 3. And my sign is still multiplication, so negative 60 is my number there. Okay, so I'll go ahead and erase this right here and go ahead and put in a negative 60. Okay, move this guy down. Okay, and we can combine like terms here, kind of clean this up a little bit here. And this whole expression, is there anything that talks to the 2? No, so I need to rewrite that guy. Well, actually, excuse me, the 2 and the negative 60 go together. What's 2 minus 60? Negative 58. Okay, and I've got a square root of 3 with both of those, so I've got minus 6 square root of 3. Okay, all right. 2 examples left for you today with multiplication. Actually, one more multiplication and then a rationalization, if you will. This is nice because, and this is a nice one to recognize because you'll see a lot of those. Those are 3 plus the square root of 7 and 3 minus the square root of 7. Again, those are called conjugates, which basically mean they're binomials that are the same except for the sign in the middle here is different, okay, on both of those, the plus and the minus. So hopefully you've done enough difference of squares and stuff like that at this point to recognize that those middle terms are going to wash away. But this time I'm going to show, as we go through here, 3 times 3 is 9. I don't know why I'm writing a 3 there. So 9, and then minus 3 square root of 7 plus 3 square root of 7 minus, watch your sign, square root of 7 times the square root of 7 is 7. And this is, see how lovely this is. This guy pairs with this guy, and those two wash away. They become 0, right? So then I'm left with 9 minus 7, which is 2. We multiplied conjugates there. Okay, and we're going to use that skill in the last thing I show you here, which is to rationalize the denominator. Again, rationalize the denominator. So vocabulary, we got to know what they're asking us to do. There is a square root of 3 in the denominator. If the directions say simplify, I'm not allowed to leave that there. So the last thing I need to do, what I need to do here is get rid of that. Well, they just showed us in the last example that if I multiply by the conjugate, the square root sign in the middle is going to go away. So I'm going to multiply this bottom by 4 minus the square root of 3, his conjugate. Well, if I do that on the bottom, I have to do that on the top. Ugh. Otherwise, I'm not multiplying by a form of 1, so I'd be changing a value. Don't want to do that. Okay, so here we go. So now to wrap this up, we just need to multiply the top, multiply the bottom, and see what we get. Okay, so let's go ahead and do that. Okay, so on the top, I'm going to distribute FOIL. 2 times 4 is 8. Minus 2 times the square root of 3. Take the negative 3 through now, or negative square root of 3, I apologize. And I get minus 4 square root of 3. And I get minus times minus is plus, and square root of 3 times square root of 3 is 3. That's my numerator. Now I have to go through with the denominator. 4 times 4 is 16. And this time I'm not going to show, but I'm just going to draw the lines here. Minus 4 square root of 3 plus 4 square root of 3. So those go away. And the very last thing there is going to be positive square root of 3 times negative square root of 3. So I get a negative sign. And square root of 3 times square root of 3 is 3. Simplify and we're done. Okay, so 8 and 3 is 11 minus 6 square root of 3 on top. And on the bottom, 16 minus 3 is 13. Okay? And that's where we want you here for this. Hope you guys are having a great day. And we'll have your classwork when you come in. And we'll talk to you tomorrow.